Welcome, everyone. My name is Peter Corliss. I am the Director of Technical Advocacy here at ScyllaDB. Today, I am joined with Tomer Sandler, who's our Director of Customer Success and Technical Account Management. And we're going to be talking about overcoming database scalability challenges with your move with a new approach to NoSQL. So Tomer, welcome today. How you doing?
I'm good, and how are you, Peter?
Doing very good. So for people who don't know, Tomer is the person who works with all of our customers throughout their life cycle, from deployment through day-to-day operations. He works with a team of really awesome folks that are tackling and troubleshooting some of the toughest real-time technical issues you could be facing, and he plays a mean saxophone. For my own part, you'll see me contributing to ScyllaDB's blog. You'll see me hosting webinars like this and other events like the P99 Conf and the ScyllaDB Summit. And I also host some of the ScyllaDB Masterclass series things. So you can always get a hold of me at Peter Corliss on Twitter. Also, I want to, for those of you who are first time here joining us, learning about ScyllaDB, I just want to go a little bit into it. We'll get more into this in the presentation we have today. But where did ScyllaDB come from? It came actually not from the database world, but our founders were the inventors of the KVM hypervisor. So these were people with deep technical knowledge of how Linux can really get full use out of these giant cloud scale infrastructure when you have systems with dozens and hundreds of vCPUs. We'll talk a little bit about this, but the advantage of something like a ScyllaDB is that it gets far higher throughput, a lot lower latencies, and because it can better utilize your hardware, you get a better TCO savings, especially important these days. ScyllaDB is available as both a cloud or database as a service offering. We also have enterprise and even open source offerings too. And so people have recognized this across the industry, and game changers have been adopting us across the industry. So people say, well, who would be using something like a database of your caliber? And it's anybody who's got a large scale, highly performant type database. So you're talking about single digit milliseconds. You're talking about throughput in hundreds of thousands or millions of operations per second. And you're taking a look at some of the biggest use cases in the world. So you have streaming media companies like a Disney Plus Hotstar or Tubi TV or Hulu. You may have gaming platforms, Electronic Arts, Epic Games. You may have IIoT. So GE Predix is one of our big customers. You may have a lot of IoT-enabled devices, like all those Strava devices out in the wild. So there's a number of different kinds of use cases, and you can see just the range of companies that are using ScyllaDB.
Just to mention one more thing, also geolocation. So like distribution, if you need replication across data centers, many customers use Scylla with 2, 3, and even up to 5 data centers.
Exactly. So when your company is looking to do global scale, we have some very specific features to allow for multi-data center replication, is called. All right. So Tomer, let's get into this thing. How does a company know when they've hit the wall with their current database?
So it will most likely be noticeable performance impacts around the P95 or the P99 latencies, and sometimes even unavailability or something that can lead to timeouts due to prolonged latencies. Somebody might be complaining about something. So either the users are complaining about sluggish user experience, or the infrastructure people will be saying we've exhausted our resources, or the developers will be saying that they are seeing some weird behavior in the app from their end. In the worst case, you'll have a combination of all three, and in the absolute worst case, it can also lead to an outage.
I think it's also important, though, that because there's one thing when you can watch the load is growing and you can watch your disk utilization growing, and it's kind of predictive in that. But then every once in a while, you'll have a stochastic event, some major real-time event. Maybe it's something you can predict, like a Black Friday coming up. Maybe it's something that you wouldn't be able to predict. So can you talk a little bit about those kinds of things where people should, maybe they haven't hit the wall yet, but they probably don't want to. They don't want to find out the hard way.
Yeah, so there we have a few customers that have a specific event that they know, like Black Friday or a specific sporting event or playoffs. Customers like Dynamic Yield, Gum or Fanatics. They need to be prepared for such events upfront. So they would probably plan for it, they do some sizing recommendation back and forth with us, and eventually decide on the sizing and start increasing their cluster size to hold the increased capacity, which can be sometimes 3x the throughput or more, about 2-3 weeks upfront. Just because scaling can take time, and we will talk about it in the later some of the later questions. There's data streaming involved, but yeah, they need to get prepared and have the capacity to handle the expected throughput, not to find out about it in real time when things start to get laggy.
Right. Now, the other thing too is that sometimes your performance impacts are not consistent. Like you might get spiky performance at times, right?
Yeah. That can also happen as well. Yeah, we have a very big customer that had both that was using Cassandra and was having a huge node sprawl because of some limitations of Cassandra of the maximum data to store per node. So the number of nodes had to grow, and that can reach tens and even hundreds of Cassandra nodes. Having many nodes, you are also more prone for hardware issues, disk failures, and there's a lot of cross inter-cluster communication going on. So the more nodes you get, the more communication going on between all the nodes, which can also lead to unexpected spikiness and in your latencies because of that inter-cluster huge traffic when we're talking about tens and hundreds of nodes versus under 10 nodes.
Right. Now, so that's one thing. There's the system itself could be hitting a wall.
Yeah.
It could also be your team managing it is hitting the wall.
Exactly. So the more complex the database is, the more attention it needs by people monitoring it, monitoring the hardware, monitoring a lot of things. And when failures happen, people need to jump on it, start doing procedures like replace a node, replace a dead node. And so all this stuff definitely have human capacity factors here. And for that, there's also, of course, managed solutions that can alleviate that.
Right. And I think the third wall that people hit is just the affordability wall, right? They finally see the bill and they go, we can't, we've hit a wall fiscally, right?
Exactly. So many times, a lot of managed services like DynamoDB, for example, very good managed service, but it comes with a price and a bill. And sometimes when you started small, you started growing, and suddenly you see that you're not on a node sprawl, but on a dollar sprawl because of the bill that you will get from DynamoDB.
All right, let's go on to the next question here then. What about throughput limits? What's different if you added more workloads or bursty time of day traffic?
Yeah. So there's some software that can handle overload conditions better, but no matter what, you're going to be seeing problems like timeouts or increased latency. So it's important to know how your system is going to degrade beyond the peak performance. It doesn't matter how good your hardware resources are if you underspec your infrastructure versus your real world production traffic needs. And we just talked about it, like getting prepared for events like Black Friday or a specific sporting event. Nothing replaces good planning, sizing, and good observability. You want to look ahead into longer periods of times, beyond a week or even a month. You want to see the rate that your data grows and plan for the future. And then you can extrapolate on that and to know when you're going to be hitting a wall and not hit it unexpectedly.
Right. I think the other part of the second question here is interesting because there's a lot of people who they say, oh, well, the infrastructure's there, the data's there. Let me just add in this, repeating full table or partial table scan.
Yeah, exactly. So sometimes you started with specific workloads and use cases, and the cluster was sized for that. And suddenly you get more use cases or some analytics workload that somebody just like sneaked in without telling anyone. We saw several customers that started with 1 or 2 use cases and came back complaining about latency or timeouts issues. And then we found out that they're running 12 and 14 use cases on the same cluster. And somebody thought that, hey, it could just hold. Surprise, it cannot. The more workloads and use cases you put on it, you need to reevaluate your sizing. And the best would be always, of course, to consult with us and our solution architects on that.
Yeah, I think what's interesting is that we have this feature for workload prioritization. Why don't you talk a little bit about that?
Yeah, so workload prioritization allows you to alleviate some of those pains by deciding which one of the use cases or the workloads is more important to you, and that one will be getting more resources, compute resources, network resources, etc. You can basically create, you use authentication in users, and you create a role for each user, and you assign a specific compute and other resources shares to each one of those roles. And that's how you can control that, let's say you have a user, which you will call it analytics, and that one will be attached to a role, and that role will be getting, let's say, only 20% of the shares. Okay, so like you want your real-time traffic to get the 80% and the analytics to get 20, so you know that it cannot overcome or choke your real-time traffic, which are the ones that you care most. Analytics usually is something that can run in the background a little bit longer, depending on the use cases. And there are other ways, by the way. You can segregate workloads to different data centers. That was like the old way. Before workload prioritization, you would have a data center for analytics and a data center serving mostly your real-time traffic.
Right. And again, I think that workload prioritization, people need to understand it's not a replacement for actually having a properly sized cluster. Because if you're constantly running into contention, you probably want to grow that cluster a little bit, and then you can apply workload prioritization and say who has the best shares. But that's not the same thing as pretending that you're running twice as many nodes and you can handle all the workload you're throwing at the system.
Exactly. You just want to make sure that if other use cases, some of them might all be real time, not analytics, and some of them suddenly might have a spikiness, unexpected spikiness. You don't want that to hurt another real-time use case that you think is more important to you, or it's more user sensitive, or it has a more strict business SLAs.
Right. So even within OLTP workloads, you can say which has the higher priority.
Yeah, exactly.
Awesome. Thank you. Let's go on to the next question here. Even with the best upfront planning, you can run into a stochastic event that can go beyond your predictive planning. What then?
So that's when you add capacity to the cluster as fast as possible, and we call it something like emergency scalability. Okay, so that's when you just have you hit something that was either unexpected or you didn't plan properly, and now you're into the situation where you are getting those latency issues or timeouts, and you have to scale right away. And that's an emergency scalability. And for example, we have a customer named Kiwi that had something similar, not exactly like a stochastic event in the sense of additional workload, but they were running on 3 data centers and 10 nodes in each data center, and there was the OVH Strasbourg fire that basically disintegrated and killed one of the data centers completely. And immediately they lost 10 nodes, which was a third of their compute, and also some application clients. And what they did, because they planned properly to even be able to handle a complete data center failure, they were spread over 3 data centers, and they could just route their real-time traffic to the other 2 data centers, which were sized good enough to hold all the traffic, although they were having alleviated traffic, like roughly 50%. Each one was getting 50% more because the third data center that went away. They were able to continue serving in real time until the OVH Strasbourg data center was recovered. And then they were able to even acquire better hardware and reestablish that data center, add it back to the cluster, and go back to the original state.
Yeah. Now that's a catastrophic outage. I think there's also, for instance, there's sometimes when a database's performance may be affected, for instance, even by by hackers, like distributed denial of service. I think we added a per partition limit to kind of like reject traffic if it's going above a certain limit. Wasn't that another thing we added recently?
Yes, we have a few limits that can help with such events. When you have something like hackers trying to do a denial of service, or sometimes they just try to initiate like big scans on your data because they know that's going to be painful.
Hmm.
There are all kinds of limiters that you can play with and see those messages coming in the Scylla logs, and you can understand that something might be going on, and then you can also go and tune those limiters to be more aggressive or less aggressive.
Awesome. Okay, so we're going to go on to the next question here. So let's define emergency scalability. You talked a little bit about it before, responding to these unplanned demands on your system. So you talked about the OVH Cloudfire. Are there any other emergency scaling instances that you remember? Any situations where people had to do that kind of emergency scaling?
Yeah, so first of all, and most important is using bare metal in an on-premise environment and not having sufficient resources to continue to scale. So if you're using bare metal and you have a bare metal situation that you need to scale, then you need to get, first of all, if you don't have the additional hardware just lying around that you can immediately swoop it in and start deploying more Scylla nodes on it, you'll have to go through procurement and deployment cycles, and that could also prolong.
That could take weeks or months, even. Yeah.
Exactly. So when you're using bare metal, you have to ensure that you have hardware standing by for such incidents. Otherwise, your emergency scalability will be very long.
Mm-hmm. Well, this could also happen on the hyperscalers, even on the public clouds. They may not have the type of instances you want in a certain region.
Exactly. It can be a lack of resources on the cloud vendor part on a specific region, sometimes even on a specific availability zone, which is something that you need, which then will require you to introduce another availability zone into the cluster. And it's not that it's not doable, but it just creates more complexities. And there are other resources that might be missing either on the cloud vendor person or on your end, like all kinds of resource limits that you purchased with the cloud vendor. And again, all these things are fixable, but it can introduce another 24, 48 hours delay. And when you are under fire, you want this done in a matter of hours.
Mm-hmm. The other thing that I heard about, specifically when we go back to the Kiwi.com example, was that the ScyllaDB itself was operating fine, but there was a number of ancillary applications and services that surround a database, and those needed to be mitigated. So it wasn't the database itself, it was everything was connected to as well.
Exactly. So again, your application needs to be built in a way that they could survive and immediately be tuned or redirected to another data center. So if, for example, you were using specific hard-coded IPs on a specific data center that went down, that's something you'll need to figure out and then start pointing them to another location. So, for example, might be using some joint DNS names that are globally known by the cluster that might alleviate and will help the application immediately get connected to another data center. So there are also considerations from the connection method on the application side.
Mm-hmm. Now, I think that to me, like one of the key facets that people have in their mind, one of the holy grails that they have is kind of like intra-hour emergency scaling. So like something's happening, a news report, and they would hope that within 10 or 15 minutes, the cluster could double to handle demand. But I think that those right now, given the current limits of technology, is kind of we wouldn't be able to do that. So what other kind of limits should people like plan for? Again, unexpected intraday bursts. How would people be able to handle that today?
So again, you need to make sure that you look at all your resources. There will be data streaming, heavy data streaming involved when you need to increase your cluster size. So you would need to make sure that you created your cluster with sufficient network bandwidth. So let's say using 1 gigabit network is kind of a risk by itself already, even when you're just handling your regular traffic. So try not to use anything below 10 gigabit network. Some bigger nodes on the cloud even comes with 25 gigabit network. Some of these networks are only for spikes of traffic, network spikes, and some of them are guaranteed. So that's another thing you need to look into, whether you're guaranteed that bandwidth or it's only for spikiness. Some databases like DynamoDB will enforce throttling on you, okay? When you try to bombard the cluster with a lot of traffic, even if the cluster has auto-scaling, for example, okay? So there's auto-scaling possibilities, but in the meantime, most of the solutions out there for auto-scaling will need to throttle you while they auto-scale.
Yeah, now ScyllaDB is being a little bit proactive here, just for the audience's awareness. And you'll hear more about this at ScyllaDB Summit. So I don't want to ruin it's not a surprise, but I don't want to ruin Kostja's talk. He's going to be talking about how we're changing ScyllaDB so that right now, when you're trying to do scalability, you add a node, the cluster rebalances and quiesces, and then you add another node, or rebalances and quiesces. And we're adding some new raft capabilities to be able to add any arbitrary number of nodes so that you could scale up or scale down by multiple nodes at once. So there will be some stuff that you guys want to tune into later in 2023, especially be there at ScyllaDB Summit to learn more about how we want to make a better database to deal with this kind of emergency scalability.
Exactly. The raft is going to be a big game changer. I highly recommend tuning into those presentations.
Yeah. All right. So you already talked a little bit about this, but the difference between doing emergency scalability with an on-premises deployment versus public cloud. So I think we already talked about.
We already cover it in the sense that there are other limitations of what we call things that can grow the pain time, lacking of hardware in a specific region or availability zone, lack of resources, network limits, the number of subnets that you have, the number of VPCs that you have, all kinds of quotas that you are currently on. And sometimes you were already reaching those quotas or very close to reaching them, and now you need to go beyond them because of that emergency scaling, and you need to contact your cloud vendor account manager to increase your quotas. So these things can also happen definitely on the cloud. So it's not like the cloud is without any flaw compared to bare metal.
Exactly. But there's even financial considerations, like beyond just the technical challenges you face. Companies will consider an on-premises thing a capital expenditure with depreciation schedules and all this kind of stuff. It's a different procurement system than your operational expenditures when you're doing on the cloud. So it's just the kind of thing that for people who are doing not just, delivery of this stuff, but if you're a manager out there and you're trying to balance this stuff, there's a completely different way that you might have to approach your upper management to get this supported for you.
So budgetary constraints, sometimes the software budget and the hardware or infrastructure or platform budget doesn't come from the same departments or the same procurement, another kind of considerations for internal processes. Yeah.
Right. Okay, so is the cloud really just someone else's computer?
The short answer is yes. Of course, it eventually runs on computers. This is not some amorphic thing that hovers around in the stratosphere or something. It's eventually all hardware, and any cloud vendor can run out of computers or servers, and you can run out of quotes or VPCs or subnets or any other infrastructure resources. And those, of course, will be something that you need to mitigate with your cloud account manager, your cloud vendor. So yes, being on a private or a public cloud doesn't mean that it's without its flaws. Even if you're running on virtualized or containerized systems like VMware and Kubernetes, there's always bare metal under anything eventually.
Yeah, and I think the other thing too is that some people think like, well, even if I'm using a managed service, I don't need to worry about observability or metrics or anything like that. But we have cloud customers that are asking for data, for instance, in Prometheus format for ingestion into their Datadog. Even if it's a DBaaS, they still want to manage it like the rest of their infrastructure.
Exactly. So first of all, a lot of customers do care about observability for their application clients, okay? But they do, and I highly recommend to be also on top of what's going on in the database. And
Hmm.
in Scylla's case, in Scylla Cloud, our managed service, we have our Prometheus, our monitoring stack, which is based on Prometheus and Grafana. And you can consume all those Prometheus metrics to your end, to any monitoring system that can consume Prometheus metrics. It can be our own, a local monitoring stack that you deploy locally on your end, and you consume the metrics, and then you can also tune the dashboards and the panels as you see fit, create your own, or you can consume them to any centralized monitoring system like Datadog. We have good integration with that, and then you can also, of course, apply all your logic, business logic for alerts and PagerDuty and other things that you would like to monitor on your end as another precaution measure beyond the managed service and the things that are monitored, because not always everything is monitored in real time. There are things that we do track in real time, and we have our own alerts for those, but there's like thousands of metrics, and you cannot have an alert for just about any metric, but there might be some specific metrics that are of interest to you. For example, then the metric that looks at the cache evictions, for example. If you're doing a lot of cache inserts and cache evictions, this is something that can worry you. Maybe you're doing prepared statements incorrectly. Maybe there's other things that are going on, and you're basically spamming the cache with data that should not enter and evict from it all the time. So there
Right.
are a lot of things that you can care about.
Or maybe you're making queries that are inefficiently using a cache. Maybe you should be using a bypass cache.
Exactly. So those are we call like scans that you just want those for analytics. You don't really want those to go into the cache and evict the other entries that are do needed for the real-time traffic. And in such cases, yeah, using bypass cache would be one of the means to overcome it.
Awesome. Okay, next question. Is data volume itself a barrier to scale? I want a petabyte of storage fully loaded by 8 a.m. tomorrow.
So of course, when you are scaling your database and provisioning more machines, it means you will need to join them to the cluster, and that cannot happen in the case of Scylla or Cassandra. You cannot join 20 nodes at once. It needs to be done sequentially, one after the other, and there's a lot of streaming involved. So one node is starting to join the cluster. There's streaming. The token ring gets rearranged and all that, and then you add another one and another one and another one. So this, of course, takes time. But I mentioned that earlier. Maybe you have enough storage and you spec your storage properly, but you didn't spec your network. And when there's streaming involved, your network is going to be heavily engaged. Okay, there's going to be a lot of reads from disks on one end, and there's going to be a lot of network traffic going into the writes on the other side to the newly joining node. And if your network is, as I mentioned, 1 gigabit, for example, you might be bottlenecked on the network, and then you're just waiting for the streaming to happen in the speed that the network can support it.
And the opposite could be true too. It could be your storage that could be a bottleneck, right?
Exactly.
So another talk we're going to have at ScyllaDB Summit is ScaleFlux, who is making some advanced SSD systems, and they're partnering with Ampere to show you how you can use even an ARM-based system to get really high performance. So I think that you always have to take a look at the complete solution that you're working on. For AWS users, I would suggest right now your best option for an instance would be the i4i, really high performance Intel processors and their fast Nitro SSD architecture. Those make for a good pairing. And again, like Tomer's saying, you needed the network IO as well as the rest of this all working together.
Exactly. So there could be various bottleneck points, and you need to look at all of them. So it can be storage, like you mentioned, network, or it can be your compute components, the RAM and the CPU. Maybe your disks are too slow. Maybe you're using EBS drives and not locally attached SSDs. Maybe you are using SSDs, but you're not using NVMEs. And of course, each one has its trade-off of more performance, but costs more. But most of the time, the high-performance disks are not that expensive anymore, and you should for sure utilize them for anything that you want high performance with. Don't go cheap on disks, and don't go cheap on your network or your compute.
Yeah, and then there's another thing I want to bring up too, which is also compression, right? So in fact, we have a benchmarking petabyte scale NoSQL workloads with ScyllaDB, and part of storing a petabyte of data is actually the fact that that was the raw data, but you can keep that in a compressed state as well. But here, there's even different choices in trade-offs between when you're doing compression. Do you want to do something that has a really good storage savings to get the maximum amount of storage out of your disk? Or do you want to have something that's more performant in terms of compression speed or decompression speed? Because different algorithms will optimize differently for compression, whether for speed or for storage savings.
Exactly. And I was just writing in our chat, was posting that petabyte benchmark that you were talking about. And some people ask about, is there benchmark information? There's lots of benchmark information on our website, including a comparison benchmark between us and DynamoDB, us versus Google, Bigtable, and other databases. And there are just benchmark only on Scylla and Scylla versus Cassandra, many of those, on how Cassandra, for example, would need 10x the number of nodes to fulfill what Scylla can do with 10x less the hardware.
Yeah, exactly. And for this petabyte benchmark, there was we actually used another vendor's setup, and we compared on the exact same hardware, very similar hardware. I think that the only difference was that one had bare metal and the other one had the hypervisors. But other than that, it was the same number of vCPUs, same number of disks, and we were able on ScyllaDB to get 40% greater throughput on the exact same hardware.
Exactly. So there's also the Scylla architecture and the sharded architecture. The fact that we are sharding the entire data, and each shard, which is like a subset of a CPU, or basically equals a virtual CPU, is like its own mini database. It has its own resources for disk I/O and disk access, network, and others, and memory. So the parallelism power of Scylla, the amount of parallelism that can happen with many shards working in parallel to serve your traffic, that's one of the greatest things in the Scylla architecture that allows us to get these results.
Yeah, and that was one of the things we saw in some of these competitive benchmarks, was that we were able to do data loading at like a massive, I'm talking maybe like 5 million operations per second in terms of like loading up data onto the servers. Other systems were choking just on data ingestion. We hadn't even gotten to the transaction part of the benchmarking, but just ingestion itself was being choked off because you have all of these loaders that are trying to get data up into a system. So when we're going to have, by the way, we're going to have Benchant is going to be talking about how to properly do benchmarks with ScyllaDB. They will also be at ScyllaDB Summit. So I really recommend people to sign up for that one, because if you do want a petabyte of storage fully loaded by 8 a.m. tomorrow, there's better and worse ways of trying to do that task.
Exactly. So sometimes it's also the database capacity to handle multiple clients or many connections, having the connections balanced in the cluster properly.
Right. Are you using the shardware clients, right?
Exactly. So if you are utilizing all the best practices of Scylla, it can be a really a mean machine versus other databases that throwing more loaders on it will basically make it choke. In Scylla's case, there are best practices that you can and you should fully utilize all the capacities of the sharded architecture. What we do see sometimes is customers complaining about not hitting their throughput target goals in some benchmark or POC, is because they're not fully utilizing. So they didn't throw enough loaders or enough connections or enough concurrency but not unlimited concurrency on the cluster to fully utilize its power. And we're basically showing them that, hey, you have like 40 shards here, and you're basically using like 25 of them, 15 are just idle. So just add more loaders and distribute your connections properly.
Right. Okay, let's go on. Number 8. What are other real-time limits you can't avoid, like the latency of the speed of light or the raw time to actually stream the data to the hardware? So why don't we talk first about the latency of the speed of light? This is where I think maybe you can explain now why multi-data center replication is so important.
So yeah, there's many use cases where you need your applications to be close to the database. Okay, your applications can be very widely distributed. For example, Stadia Maps, which is a Scylla user, and they need to serve their map use case in few milliseconds, or Strava that we mentioned earlier, that has users all over the world. So why should a user using either his Strava app on his mobile or whatever being located in India be connected to a data center in the US, for example, okay? So when you want to have multiple regions coverage and multiple data centers, you need cross data center replication. You need your data to be available in each one of them. And that will benefit, of course, your application client's latency. There are other things that you should need to look onto from the application side. So to use the data center DC-aware round-robin policy in your connection method, and make sure to define which data center entry is considered a local data center. Otherwise, that client may try to connect to a remote data center. But beyond that, the other benefits are, of course, high availability. So this is like, so many times customers prepare for a rec failure or an availability zone failure. But what happens if you have a data center failure? Okay, you might just need to transition to another region. And in that case, we mentioned the Kiwi situation. Each one of the data centers, per their business requirements, has to be at least 200 kilometers apart from each other. Okay, so it sometimes can be in the same continent, but a few hundred of kilometers or miles apart. But of course, it can be in different continents as well.
Right. I think the other thing, like when we talk about the latency issue, ad tech has a lot of use cases where they need to respond. I think they're given like 5 millisecond latency SLAs.
Yeah, they usually give the database portion around 5 milliseconds, because the bidding process usually is supposed to be within 30 milliseconds total, and the database has maybe 5 milliseconds to fulfill the request in that 30 milliseconds overall.
So these are not quite sub-millisecond SLAs, but we're talking low single-digit millisecond SLAs.
Exactly, very, very low. And again, it takes time to scale. So if you need to stream your data, Scylla does have the ability to leverage the hardware to the maximum, while other infrastructure software may not. But again, these are also part of the Scylla architecture, like the async parallel processing and dealing with high concurrency capabilities of Scylla that will allow you to scale, to stream fast, and to, of course, handle a spike in throughput from your application clients, as long as the concurrency doesn't go extremely wild. Right.
Speaking about this, can you talk more about latency issues? Because you can't necessarily just throw hardware at a latency issue, because that could actually make latencies worse.
Exactly. So latency problems are not always due to lack of resources. It could be sizing and bottlenecks, but often it's just bad application design. People usually don't know how to reason latency. They think it's the software product or the hardware, or a hardware problem, but it's actually coming from the application design. They basically set themselves with bad data modeling or inefficient queries or unlimited concurrency, and all these things combined or just by themselves can get them to bad performance. So the application side, of course, needs to do that, and Scylla has very good a SQL dashboard in our monitoring that its entire purpose is to show you what you're doing right or wrong from Scylla's perspective, from the application side. Okay, it can tell you when you have inefficient queries. You can see other metrics not in that specific dashboard that will show you if your concurrency is going wild and it gets to hundreds and thousands on a specific shard, which is something, of course, you should avoid. And basically, yes, it's just observability in this case. And when you do see these kind of things, or you suspect you might have a hot partition or a large partition, large cells, there are other tools in Scylla that will allow you to enable tracing or to look in our large partition cells row system table to try and locate those specific hotspots.
Right. So this might require data remodeling, right?
Yes.
Might require a different partitioning scheme. So it seems to me like, so again, just throwing more hardware is not going to solve that because you'd carry that over to the new hardware.
Exactly. So you need to make sure that sometimes more hardware might conceal the problem, not just resolve it, and you might hit it again. So having the application best practices is very important. We have all these dashboards that I mentioned. We also have many, many blogs that explains on these dashboards and explain the logic behind what's the best way to do concurrency on a database like Scylla or Cassandra, and how to make sure that you are on all these best practices. For example, just evening out the connections per nodes and per shard. Some customers use the community drivers, which don't have shard awareness like the Scylla drivers. And in that case, they need to manage their connection pool. And many times that connection pool is not being managed properly. Connections sometimes are left just hanging there, even when those connections are not being used. So while if you will be using the Scylla shard-aware driver, it will make sure that your connections are always balanced out and you have the exact right number of connections, which is usually 2 to 3 per shard, and not go sprawling and overloading a specific node or a specific shard.
Exactly. And again, the other thing about our shard-aware drivers is when you're talking about a token-aware driver, you're getting to the right node. But ScyllaDB shard-aware drivers are getting to the exact right vCPU, so there's less intranode traffic, right? You're not being bounced from one core to another. You're going right to the core associated with that partition.
Exactly. So the token aware is like a must. Without that, it's very bad. But beyond token awareness, there's the shard awareness for the internode hops. Now, even if your clusters are properly sized, you need to understand the bigger the clusters, the more streaming and the more intranode communications, like I mentioned earlier. So there are also background operations that you need to take into consideration, and we hardly talked about them. So not just the throughput requirements, your background tasks like repairs and compactions and streaming while you're scaling, and even while you're not scaling. There's always going to be compactions happening in the background. A repair should be happening at least once a week if you're using best practices. And the things that a good architect would do is to take all these background processes in the calculation of the sizing of the cluster, not just the throughput requirements and the latency requirements, because those background processes will consume network, compute, and other resources. And even though you can, Scylla has all kind of I/O controllers that knows how to prioritize these things properly. Sometimes you cannot allow compactions to lag behind so much, because then you get to a situation where you have hundreds and thousands of SS tables and your reads starting to suffer. So,
yeah, because if some people just try and avoid compactions as much as possible, but that leads to read amplifications, right?
Exactly. So there is always a trade-off. And even though Scylla has all kinds of I/O schedulers that try to, whenever possible, allow compactions to use more resources, and whenever needed, try to limit them more dynamically. These are things that you need to take into consideration that will happen evidently when you're scaling, and even greater force when you're scaling.
Right. Okay, another question here. What advice can you give to a system architect who's planning for data at scale?
So basically, everything that we just talked about, take into considerations not only the maximum throughput requirements and the latency business requirements, but also background processes. Make sure to ask your customer about his data growth and expectations in terms of traffic 6 months from now, maybe even a year. Are there any specific events that he knows that will require scaling the cluster upfront? So a lot of things to raise the awareness and not to look just in the microscope of the current workloads. Planning will always be the way to success.
Yeah, and the one thing I've been suggesting to people is after that OVH Cloudfire, when they lost that kind of stuff, I started asking our customers, like, do you plan a torpedo test? And they're like, what are you talking about? I said, well, during your benchmarking and the full cluster's running, do you down a node and see how does performance degrade with one node down? What if you take out 2 nodes? How many torpedoes can you suffer before your system really degrades performance beyond, lower than what your SLA would guarantee? And to have that kind of foreknowledge before you go into production of what does degraded performance look like, because you can always accidentally lose a node, and administratively you might be taking down nodes or putting nodes up all the time. So I think that these are the kinds of things that people should be thinking about: is how does the system perform best, but how does the system perform under degraded conditions, because you don't want it going nonlinear.
Exactly. So you need to first always try to have, when you're going to be going big, do create a testing staging cluster and try to do all kinds of scenarios there, like killing a node, killing a rack, or an availability zone, or a data center, even if you have multi-DC. Try to see how all these things cope. Try to do all your backup tasks, all your background tasks like backups and repair. See how they work. So taking a backup on a very large cluster and then uploading a lot of data to your backup location. That's something you need to take into account. And restore. When you need to restore a very large cluster, sometimes customers forget about testing the restore procedure and how long it would take, not just seeing that it actually works. And the data is
having that playbook. Yeah.
Exactly. So you need to have that playbook, but you need to make sure that you know how to make it work, and you need to know how long it takes you to restore, so you would know to report back to your customers if you have like a real outage situation, how long it will take you to get that back. Like committing to 10 hours where de facto it's going to take you 24, that won't work. Yeah.
Exactly. All right. We have a lot of questions here, but first we're going to ask a poll, which is how much data do you have in your production database systems? So we'll leave this poll up for a while, but because we have so many questions piled up, we're just going to keep on going and try and get to some of these. So let's see what we have here. First, a question is from Nicholas, who asks, how is emergency scalability impacted by the use of Kubernetes operator? That's a great question.
Yeah, sorry, can you repeat? I was just typing an answer to a different question.
Okay, so how is emergency scalability impacted by the use of Kubernetes operator?
Emergency scalability impacted by the use of Kubernetes. So Scylla has the operator, which allows you, the Kubernetes operator, which allows you to do the orchestration of the cluster. Like any virtualization or containerization platform, this allows many times to overcome situation when you need to replace node or add more nodes in a faster manner, or it could be much more controlled, orchestrated with the operator. The only downside of that is it's another layer that makes Scylla as the software a little bit further out from the bare metal hardware. And Scylla likes to be as close as possible. So when you are using Kubernetes or VMware or any or Dockerized Scylla, you need to make sure to follow all the best practices of CPU pinning and other kinds of methods to get your performance to be as close as possible to running Scylla on a regular node without containerization or VMware.
And I'm also going to caution the fact that Kubernetes is, was designed to begin with stateless systems in mind, right? But
Yeah.
Kubernetes can always nail up a new node, but that doesn't stream and rebalance a cluster that's repairing from a serious outage. So just having the new node join the cluster does not mean that you've quiesced and rebalanced the cluster across all the new nodes. So that's the one caution I'd have there. It's not magic. Kubernetes is a useful technology, but it does not replace some of the basics concepts of the laws of physics.
Exactly. So the next question I see, what are the hardware specifics your database performs best? CPU optimized or RAM optimized or disk optimized, ARM based or Intel based? So first of all, I'm going to start with the second part. Scylla support both ARM and Intel based instances. Our recommendation per our benchmarks done on the current available ARM instances is that they don't provide currently the enough added value in terms of performance, or sometimes even they perform a little bit less compared to the Intel-based one. So even though there are those ARM instances currently available in EC2, the instances that we tested, and there's like 2 benchmarks, if I remember correctly, and 2 blog posts about that, shows that the i3 or i4i currently and the i3ENs are still better options when you take into consideration the dollar versus every op or performance that you get for every dollar. You get more for your buck still with the i3 and i4is. And hardware specifics, Scylla likes a big machine, a very performant machine. The more CPUs, the merrier, the more RAM, the merrier, and very, very strong and fast disks. Trying to put Scylla on slow disk is basically making her a wounded animal. It just won't perform well. Okay, the disks will become a bottleneck very fast because of the way that Scylla wants to send all the I/O very fast to the disk and need the response to be very fast from the disk. As for the CPU and RAM, these are also utilized a lot. Scylla is has a polling mechanism. It's always polling on the CPUs. So if you won't have enough CPUs, or if your ratio of RAM to disk is not enough, and there is a ratio that we recommend of disk to RAM, the optimized one is 30:1, but you can go up to 70 or 80:1 and not go beyond 100:1. This is our recommendation of the disk to RAM ratio.
Yeah. So and then the only thing I wanted to clarify with that is for the disk, we prefer directly attached NVMe SSDs, right?
Yes, don't go with any SAN or NAS solutions. And again, not that it will not work, but it will become another possible bottleneck for Scylla.
Yeah, you might have a latency delay,
Yeah.
you might have throughput delays. So that's what we recommend. But we're also listening for people who do have hybrid storage needs. So join our community Slack or join our forums and let us know your use case, why you would want to run on something other than fast NVMe.
Yeah,
Okay.
So next question, the cross-region replication and what is the optimal recovery time objective? So it really much depends on the amount of data. So if you have 2 data centers and your key spaces are fully replicated to each one of them, let's say replication factor 3, and you were running repair according to the book, so the data is sync between data centers. Basically, if you can point your application immediately to the live data centers, then the recovery time is like minimal in terms of your real-time traffic and your users. But if you're asking about how long it will take to recover the dead data center and to rebuild the data there, that mostly depends on the hardware you're using, the network, and the amount of data. So streaming 1 terabyte versus 10 terabytes versus 100 terabytes of data doesn't have the same recovery time objective. There is no explicit mathematical formula to that, but as long as you have good network and your streaming is done in a good pace, you can probably extrapolate on that. Keep in mind, there will be also compactions kicking in when wherever you're streaming in. So those will create more load on the cluster until it's fully recovered.
All right, so now we have the next question. When clusters are running hot, do you shard workload to more clusters, and is it auto-scaled, sharding and shrinking?
When the cluster is running hot. So some clarification is needed here. What does it mean? Running hot meaning it's overloaded. First of all, you need to understand that from Scylla's perspective, the shards are meant to get to 100% CPU. That's when you are fully utilizing them. Beyond that, or I would say even up to the 70%. Beyond that, you might start paying with increased latency, not necessarily. Sometimes even only after 100% utilization, you start paying with increased latency, assuming all the application side best practices are met, and it's not something on that end. So our recommendation is usually to try to keep your CPU reactor load utilization under 80% or under 70%. And beyond that, you need to start looking as to why it's reaching that. Is it just because the cluster is not sized enough for this workload, or there are other factors like specific analytics full scan that comes in and causes this spikiness or some other things. Now, as for auto scaling, Scylla does not currently have auto scaling. It is basically something that you would need to, if you're using the managed service, you would need to request, and we will follow up on that. And if you're using not a managed service, then you just need to observe that and be ready to add more nodes if needed. Sharding is something that happens when, again, when the topology of the cluster changes. So if there was increase of number of nodes or decrease the number of nodes, there will be sharding happening automatically.
Yeah, and I think that's the key point there, Tomer, is that you wouldn't add a new cluster, you'd probably add more nodes to your existing cluster.
Exactly. You will add more nodes to your existing cluster. The sharding will happen automatically as part of the token ring distribution and the redistribution of the data.
And then as far as auto scaling, stay tuned and definitely read some of the blogs that we have, because we're already talking about doing things like adding tablets using some new infrastructure based upon the RAF consensus protocol. And once we have tablets, then auto scaling, the things we're talking about, are a future possibility that is going to become more and more apparent. So stay tuned. Certainly attend ScyllaDB Summit. Read a lot of our papers where we talk about tablets, and you'll hear about some of the directions that we're going to go in. Again, not a today capability, but it's definitely something that we want to make ScyllaDB prepared for in the coming days. So there's this question here. What are the best practices to avoid critical evictions?
So what we saw until today that causes cache evictions is usually malformed prepared statements that are not really using the same prepared statement, but is generating new prepared statement over and over and over and over. That's one thing. So make sure that the prepared statements are done correctly. Another thing is that any kinds of a read heavy workload that is not real-time traffic, but is generated by some analytics, some report, or something that you don't really need to go into the cache, make sure to use bypass cache on the query level of that workload, because if you won't be using bypass cache, it will go into the cache and it will evict other data that might be needed.
All right, so thanks everybody. These are fantastic questions, and we don't want to stop it here. We would love to engage more with you. There's two ways of doing this. First of all, check out ScyllaDB University, where you can learn more about how ScyllaDB works under the hood. And again, if you're a developer, or if you're DevOps, or whether you're a systems administrator, there's different courses available for your specific role in ScyllaDB University. It's all online and it's all free. There's even now a new forum system, and there's also, we have our user Slack. So bring those additional questions to our community. We'd love to answer them. And if you want another live opportunity to talk to some of our folks, check out this ScyllaDB virtual summit, and that'll be on February 23rd. Again, we'd love to just hear what questions and problems you're trying to solve and see if ScyllaDB can be the best database for your use case. With that, on behalf of Tomer, on behalf of myself and everybody here at ScyllaDB, I just want to thank you for joining us today. And here's all the ways to keep in touch with us. With that, have yourself a fantastic day.